All right, guys, I'm going to do a tree diagram. I'm going to go pretty fast, and the main reason I'm going to go pretty fast is because it's Friday, and I want to get going. So let's start with Sammy. She's worried she's going to be late for pictures, and this is on prom day. On a day with no rain, she's running late 10% of the time. All right, this 10% is based off of the condition. Give me a second here. This 10% is based off of the condition that it's not going to rain, okay? On a day when it's raining, she's running late 80% of the time. So this percentage right here is based off the condition that it's raining. The chances of it raining on prom day is 0.25. Okay, so what's going on? It's prom day. You need to think what's going to happen first. Is she going to be late or is it going to rain? Well, she's going to be late or not late based on the condition that it's going to rain or it's not going to rain. The chances of it raining is 0.25. We know that these branches have to add up to 1, so this is 0.75. I'm done with that probability. I'm going to cross it off. 80% of the time, it's rainy. She's running late. She's late, 0.8. That means when it's a rainy day, she's not late 20% of the time. How do I know that? These branches need to add up to 1. I'm done with 80%. When it's not raining, she's late 10% of the time. So late, 0.1, not late, 0.9. How do I know it? Yeah, that's right. The branches have to add up to 1. Now we're going to ask some probability questions based off this probability tree. Don't stop there on the AP exam. If you do a tree diagram, you need to go all the way through. What do I mean by that? Define the sample space. That's every outcome that could happen on prom day. Sammy could be, it could be raining and Sammy's late. It could not be raining. I'm sorry, it could be raining and she could not be late. How am I getting this? I'm following my branches. So rain and late. Rain and not late. No rain and late. No rain and not late. How do I get my probabilities now? I need to multiply across. So no rain and not late would be 0.75 times 0.9, which gives you 0.675. No rain and late is 0.75 times 0.1, and that's equal to 0.075. Rain and late, and not late, excuse me, is going to be 0.25 times 0.2, and that's going to equal 0.05. And then finally, rain and late, that's going to be 0.2. Now, these numbers right here are the numbers for which we base our probability questions off of. Let's covering it up a little bit. Just give me 1 second, because my board's not calibrated.
Kennedy, Kenton, could you please go to the front of the building? Kennedy, Kenton, please go to the front of the building.
All right. Next, I'm going to take a picture of this, and we're going to answer a couple probability problems. Okay, I suspect if you do have to do a probability tree, it could be on the multiple choice. If it's on the free response test, what they're going to do is they may ask you part A, and they may say, what's the probability that she's late? Okay, well, there's 2 places she can be late. The probability of raining and late, or the probability of not raining and late. So you're just going to take 0.2 plus 0.075. which is equal to 0.275. Now, the next thing they may ask you, it's what's the probability that given she's late, it rains? Okay, now this is where we're going to do the conditional probability. We've been practicing a lot in class. And the denominator needs to be every way she can be late. So that was part A. She can be raining and late or not raining and late. When we figure out that probability, that's 0.275. Next, in the numerator, we need to take and do both rainy and late, which is right here, raining and late, 0.2. Then we type this into our calculator, 0.2 divided by 0.275. Sorry, my calculator was not on. 0.2 times 0.275, and that gives us 0.055. The last question they might ask is being late and if it rains or not independent? So I could set it up like this. I'm going to call this part B. In part B, I already found a conditional probability. The probability it's going to rain given she was late. So every way she can be late in the denominator and the numerator both, we divide it and we get 0.055. In order to establish independence, we have to use our conditional probability, the probability that she's raining, given it's late, and it needs to be equal to the probability of rain. This is how we prove it mathematically. We already figured out this answer in part B, 0.055. The probability of rain is already defined as 0.25. This is not equal, so they are not independent. All right, that's tree diagrams. That's talking about conditional probability and independence. Hopefully that helped.